I need somebody help, not just anybody help. You know I need someone help. When I was younger, so much younger than today.
Hi scholars, we're going to do a couple of examples where it makes sense to use fractions to represent part of some other larger whole. So for example, on average 2/3 of people in a grocery store buy an item that is on sale. And we learned that 150 people shopped at the grocery store yesterday and 36 people shopped today. And they're asking, over these 2 days, how many people bought an item that was on sale? So we could do this a couple different ways. I could say 150 people yesterday, 36 people today means that over those 2 days, 186 people, right, shopped at this grocery store. And we know, right, that 2/3 of that amount, that 2/3 of 186, this is the amount of people who got the sale. That's what it says. It says 2/3 of people buy items that are on sale. So 2/3 times 186, you could plug it into your calculator, you end up getting 124 people, which is the answer. That's how many people got the sale. Now we could have done this in a slightly different way where maybe we don't have a calculator. Could we just do this sort of using mental maths? We definitely can, right? When we took 2/3 of 186, we were really taking 2/3 of the number of people yesterday and the number of people today, right? We could kind of use the distributive property and think about, can I just focus on 2/3 of 150? And then I'll focus on 2/3 of 36. Well, 150, can I divide it up into thirds? Sure. 150 is 50 plus 50 plus 50, right? So there they are. There's 1/3 of 150, and here's 2/3 of 150, right? 2/3 of 150 is nothing more than 100. Plus 2/3 now of 36. Well, what's 1/3 of 36? Put differently, what's 1/3 of 36? Or what's 36 divided by 3, right? These are the same questions. So 1/3 is 12. We know our multiplication tables. So 2/3 is 2 of those 12s, right? This 36 is nothing more than 12 plus 12 plus 12. So this is 1/3, 2/3, 3/3. So 2/3 is 12 plus 12 is nothing more than 24. And I'll be darned, 124 people. Okay, let's take a look at another example. Theo ate 1/3 of a cookie. Then Gnarly ate half of what was left. After this, what fraction of the original cookie is left? So we can do this a couple different ways. So one way is sort of visually. So let's say here's our cookie. Let's divide it up into thirds, right? And it says that Theo ate 1/3 of the cookie. So he ate this part. In other words, this is gone. It is in his stomach, right? And we can ask ourselves, what's left over? What is remaining after he eats 1/3? Well, this is remaining, right? This whole part of the cookie. So 2/3 is left, right? Now, algebraically, we say we can say I start with one cookie, right? I take away 1/3, and I'm left with 2/3 of the cookie, right? So that's fine. So now we have 2/3 of a cookie, and now what's going to happen? Gnarly is going to come and eat half of what is left. So this is sort of important, right? So eating half of what is left. What's left is just everything in blue. Let me redraw it here. So this, more or less, this is not a great picture. This is what's left. So he ate half of it, okay? So he ate half of it. Now this part's gone. So what is remaining is right here. What fraction of the original cookie does this thing represent? This is 1/3, right? This was our original third here, okay? Now algebraically, we could have done this sort of in a more direct way without the picture of the cookie. We could have said Theo ate 1/3 of a cookie. So here, I have some cookie. Let's call it X. Great. Theo ate 1/3 of it. So what's left over? Well, what's left over is 1 minus 1/3, otherwise known as 2/3, right? So now I have 2/3 of a cookie. Gnarly ate half of what was left. So Gnarly comes along, and he eats half of this, right? Now look, half of, we're multiplying here, right? We can multiply everything, and we get 2/6 of x, which is otherwise known as 1/3 of x, 1/3 of the cookie, right there. That's the third.